Hi, I'm John Holden.
And I'm Andrea Ocampo.
Welcome to Earth. Hi, I'm John Holden. Welcome to Earth. We're starting off our story here in Ottawa, Ontario, the capital of Canada. And behind me, this Gothic Revival style building is known as Peace Tower. It's part of Canada's Parliament Hill. It's a group of government buildings along the Ottawa River. Now, the Peace Tower is 6 stories high. That's about 322 feet. And as an environmental reporter, of course, the first thing I ask is, how do they heat and cool this thing? Air conditioning and heating buildings significantly contributes to global warming. It takes plenty of energy to run an air conditioning system, even the most energy efficient buildings. They also leak hydrofluorocarbons, or HFCs, directly into the air, depleting Earth's ozone layer. To reduce the impacts of heating and cooling, researchers look for ways to make these systems more efficient and to run them on cleaner fuels.
A zero-carbon building is a building that doesn't have any emissions associated with its operations over a 12-month period. So in order to become a zero-carbon building, you have to identify all the fossil fuel consumption in the building, develop a plan to phase that out, and actually perform over a 12-month period without any carbon emissions.
Sometimes we can just dress accordingly if it gets a little too cool or warm inside, but not here. These guys need hard ice, and lots of it. This is the AMPT Sports Lab and Ice Complex in Ottawa, Ontario. As a one-stop facility for hockey development, AMPT houses an ice rink for training, a 4,000 square foot gym, physiotherapy rooms, and a pro shop. All that requires a lot of energy. But this is also the country's first zero-carbon building performance standard arena, certified in 2020 by the Canada Green Building Council.
Well, for this building, it was the first arena to achieve certification. And if you can think about an arena, it's a very energy-intensive building. We got this ice pad behind us. There's a lot of dehumidification and energy use associated with that ice. So for us, it was the first time we had really gone outside that traditional office and multi-unit residential market to certify a building with such high energy loads.
The AMPT complex's environmental footprint was reduced by the work of Modern Niagara, one of Canada's largest electrical, mechanical, and integrated building technology firms.
AMPT as an ice rink is something that was exceptionally challenging. Had to plan ahead a lot with the fluctuations in the Canadian climate. Definitely looking at things like the desiccant units to help manage the humidity and the heat, but also manage the cold in a way that is very robust for the ice hockey players. The technical challenges as well as the human performance challenges involved meant that our team had to be very creative and very technical in their delivery. So this was a project that could withstand the test of time.
And we chose AMPT because we figured, hockey arena, it's got a lot of cooling requirements, it's got loads that a lot of other buildings aren't faced with, and we felt if we could do it at AMPT and in an arena, that would kind of set the bar very high in terms of if we could do it there, we could probably do it in any building.
Modern Niagara's overall design objective was to reduce the AMPT complex's energy consumption by at least 40%. That required technicians to look at all aspects of the building's internal systems and figure out how to replace natural gas with renewable energy.
A hockey arena is a very energy-intensive building. What solar panels allow us to do is we typically use air conditioning when the sun is shining outside and it's warm. Well, that's the same time when solar panels can generate electricity. So why not reduce the peak load that this building requires by putting solar panels on the roof? It's not as simple as just looking at one component of the building. You have to look at a number of things to do that. You have to think outside of the box, and you really have to look at the facility from a life cycle cost aspect, not just the installed cost. So you have to look at the cost of a building over time, and that's what makes it possible to actually achieve the energy reduction.
For instance, Canada has passed legislation pledging to move the entire country to net zero emissions by the year 2050. And Modern Niagara has pledged to be an active partner in reducing building emissions in modern structures like AMPT, and even in historic buildings like what you find here on Parliament Hill.
I see Modern Niagara's role as it relates to climate action, and specifically obviously the building industry, is that over the last 62 years, the entire history of our organization, we've developed the skills and abilities where we can have a big impact on decarbonizing buildings, which is going to be a critical part of Canada and, quite frankly, the entire world achieving the targets that have been set in the Paris Accord and other commitments that countries have made.
Modern Niagara's work proves that real cost and energy savings is possible in almost any building, greatly reducing its eco-footprint. And you know, that's a real challenge, a real exciting goal, almost as exciting as that winning shot in hockey.